Hello everyone, my name is Big Pathanamon Thong Tanonam, and today I'm very happy to present our paper titled Workload-Aware Reviewer Recommendation using a multi-objective search-based approach. And this paper is a collaboration with Hua and Aditya and their student Win Sam from University of Wollongong and Kla from Monash University. So before I move to the next slide, let me celebrate the acceptance of our paper. Yay! Now let's talk about our paper. What is code review? Code review is a method to improve the overall quality of a patch through manual examinations. So let's assume that I'm the author of the patch or the set of code changes, and now I create a patch and upload a patch to the code review tool. And the reviewers, which is Kla and Hua, will help me to review the code to identify defects or even provide a suggestion to improve my patch. Several studies have shown that effective code reviews actually requires active participation from the reviewers. Moreover, a patch tends to be less effective when it was reviewed and discussed extensively by many reviewers. So now the challenge is that how can we find a suitable reviewers who can help the patch author to review the code? And my previous work also showed that finding a suitable reviewer is not a trivial task, and finding a reviewer should be done very quick in order to improve the code review process. So, to address this challenge, several works have developed reviewer recommendation approach to help developers find suitable reviewers. And most of the existing work focus on the expertise or experience of reviewers, and they try to find reviewers who have reviewed many similar patches in the past. And more recently, the recent approach try to incorporate more information about past collaboration between the reviewers and the patch author in order to find reviewers who often work with the patch author in the past. However, requesting only expert or active reviewers for a review could potentially burden them with the many reviewing tasks. And my recent work at INSEE also found that there are several human factors that can be involved in the review participation decisions. And we also find that the invited reviewers often consider their workload when accepting new review invitations. And at Google, they will actually assign the review tasks in a round-robin manner in order to consider the workload of all the developers. Therefore, in this work, we develop a new approach that considers all the aspects together. So generally, given a new patch that submit to the code review tool, our approach will first measure the review metrics against the new patch, and then our approach uses a multi-objective evolutionary search or the NSGA tool to find the optimal solution or the set of reviewers that meet the two objectives. And the two objectives that we use is to maximize the chance of review participation, which is based on the experience, activeness, and the past collaboration of the reviewers. And we also aim to minimize the skewness of the workloads across all the reviewers. And once we search all the solutions, the approach will suggest the reviewers who meet these two objectives. And in this work, we use 4+1 key reviewer matrix. So the first four reviewer metrics are code ownership, which is reflect the code authoring experience of the reviewers, reviewing experience, and review participation rate, which reflect the activeness of the reviewer. And then the fourth one, we measure the familiarity with the patch author, which is the co-reviewing frequency between the reviewer and the patch author. And for the workload aspect, we count the number of remaining reviews, which is the number of pending review requests. And then for the first four metrics we use in the first objective in order to identify reviewers with the maximum experience, activeness, and past collaboration. So we use the weighted summations for the fitness function of our objective 1. And for the objective 2, we consider the number of remaining review requests. So in order to identify reviewers with the minimal skewness of the workloads across all the reviewers. So we use the channel entropy to measure the distribution of the workload. So let's take a look into more detail of each objective. So here is the example for the objective 1. So let's say that we have 4 reviewers here, and then first of all we measure the 4 reviewer metrics, which are co-ownership, review experience, review participation, and co-reviewing frequency for each reviewer. And then we use weighted sum to sum all the metrics to calculate the score for each reviewer. And let's say that the NSGA2 algorithm generate a solution candidate and saying that client I should be a reviewer. Then the score for the objective 1 in this example will be the sum of class score and my score. Okay, and similar for the objective 2, we consider the number of remaining workloads. So first of all, we measure the how many reviews how many pending review requests for each reviewers, and in this case is I have 4 reviews, Hua has 1, Class doesn't have anything, and Aditya has 2 reviews. And let's say that the NSGA2 generate a solution and saying that client I should be the reviewers. So then the total workload that all the reviewer will have will be I will have 5 and Class will have 1, and the workload for Hua and Aditya will remain the same. So based on this total workload, we use the channel entropy to measure the distributions, and this score mean that the lower score mean that the better distribution of the workload across all the reviewers, and we aim to minimize this number. So the NSGA algorithms will generate many solutions based on the genetic algorithms, and it will find it will generate a set of the Pareto optimal solutions, which is a set of the reviewers that meet the 2 objectives. And in this case, we have 4 solutions as the Pareto fronts. So and from these 4 solutions, we can select one manually, or the developer can select one manually. But in this paper, we use the knee point approach to select the solution. And to do so, we measure the Euclidean distance between each solution and the reference points. So our reference point is the maximum chance of the participating review, or the maximum score of the objective 1, and the minimum score of the objective 2. And then we measure the distance for each solutions. And for this example, the solution 3 has the closest the distance to the reference points, so that we select the solution 3 as the final solution, and we will recommend Kla and Hua as a reviewer for a new patch. So now let's talk about the empirical evaluations. In this paper, we aim to investigate how well can our approach, which use a multi-objective approach, can recommend reviewers for a newly submitted patch. And in this paper, we use the dataset of 4 open source projects, which are Android, LibreOffice, Qt, and OpenStack. And then for the investigation, we investigate that whether considering 2 objectives is worthwhile or not. To do so, we compare our approach with the single objective approach, which use the genetic algorithm, and focus only one objective at a time. So we have 2 approaches here. The first one focused on the objective 1 and the second one focused on the objective 2. And moreover, we also want to investigate whether the choice of the multi-objective approach have an impact on the performance of recommendations or not. So we compare the performance of NSGA algorithm with the other two multiple objective algorithm, which is MoSEL and SPEA2. And finally, for the performance measure, we use 4 performance measures, which are precision recall F measure and hypervolume. And to compare the performance between our approach and the alternative approach, we calculate the percentage gain, which is the percentage comparison of each performance matrix. And now here is the results. And this is the result of the comparisons between our approach and the single objective approach, which is the left-hand side is the genetic algorithm that focus on the objective 1, and this one, the right-hand side is the comparison between our approach and the single objective approach that focus on objective 2. And as you can see that our approach achieved 88% to 142% higher in precision, and also about 100% up for the recall for our approach. So these results suggest that considering multiple objectives at the same time allow us to better find reviewers. And similarly, when we compare the performance between the NSGA algorithms and the other two multi-objective algorithms, which is MoSEL and SPEA2, we find that our approach achieves the performance better than the other two multi-objective approach. So these results suggest that the NSGA algorithm leveraged by our approach is an appropriate multi-objective approach to find solutions in this problem domain. So now let's sum up my presentations. Finding a reviewer is not a trivial task, and there are so many papers that have proposed reviewer recommendations which are based on the expertise and past collaborations. And yet, the reviewing workload should also be taken into consideration when we recommend the reviewers. Therefore, in this paper, we developed an approach which uses the multi-objective evolutionary search approach to find the reviewers that meet the two objectives, which are to maximize the chance of review participations and to minimize the skewness of reviewing workload distribution. And our results shows that our approach outperformed the 4 alternative approaches, which are the single objective approach and the approach that use the other multi-objective approach. So our empirical results suggest that we highlight the potentials of leveraging the multi-objective algorithms that consider the review workload and other important information to find the reviewers, and we show the promising results. Thank you very much for your attention.